Welcome to the Hararian Network, where we are connecting people through networking. And I know it's been quite a while since I posted my last video, which had to do with getting the CCNA, right, as the first certification. And I want to get away from just having a conversation type of video for now. And I want to just start getting into it and start from the very basics. And what am I talking about here? Well, I'm talking about how we should go about doing labs. So when you think about how we should do labs, what you're probably thinking is, okay, let's do labs by whatever we learn from whatever certification we want to go for, whatever steps we see, let's just follow that and make sure we go through it and we succeed and we accomplish it, right? But you have to think about it. It goes more deeper than that. And why do I say this? Because you have to really understand, of course, what's going on and what you're dealing with, right? And on top of that, the way you should learn labs, and this is a way that helps me throughout my process of learning and understanding things better, is to learn it in a way that you can put it in real life scenarios. And what do I mean by that? Put yourself in the perspective as you're working for the company and you are an engineer or an admin, or if you're in a higher level, an architect, whatever the case may be. And it doesn't matter whether it's networking, systems, cloud, cybersecurity, DevOps, software development, databases, things like that, data scientists. It does not matter. At the end of the day, put yourself in their perspective as you're working for a company and you have to set up a solution, right? And throughout that process, you're not going to go through smoothly. There's going to be problems and issues. So whenever you troubleshoot things, find out what the issue is, how you resolved it, and from there, that's how you come up with experiences and stories that you can perform and you can present when the time is right for you to bring those things up. And that's the way we should go about labs. And now that I'm talking about this, we're starting from the very basics, and that is this. We're going to create the simplest form of a network. And what's a network when it's all said and done is as long as you have two or more devices that have an IP address, and that's the way that they identify themselves, to be able to communicate with each other. If you have that, you basically have a network. And now, let's get straight to it. So, I'm going to open up Packet Tracer, but let's just see it as ourselves actually in the environment. We see the equipment and everything like that, right? And we're hired, right? And I'm one of the engineers. You're an assistant engineer with me too, whoever's watching this video. So we're engineers together. And we just have to set up something very simple, right? And what is that? The manager tells us this. So we have a project we have to work on regarding of configuring a network. But he wants to start with whatever he has for now and to see if things function and works. And what is that? He has two computers, right? So basically, he brought out the two computers. He hasn't thought about a name yet though, but let's just leave it like this for now. Maybe in the future we can think of a name, right? He's not really worried much about that, but he just wants to see if these two computers can work and if they can communicate with each other and how we're going to set that up, right? So, well, let's check the computers first and foremost and see that if they are on. Okay. Oh, pardon me. My mistake there. Yes, so don't mind that. Now, let's check. So the computer, we turned it on. Alright. And these are different ports that we can implement. We can see here, okay. And we can see when we go on the computer, checking for the settings, well, there's nothing set up for this, right? And like I mentioned, the computers need an IP address in order for it to communicate on a network, right? And let's check the Ethernet. So this is the Ethernet right here for fast Ethernet. And, well, there's two different ways we can configure an IP address. One is statically, which means we, as the engineers in networking, manually set that up. Or we can have a protocol like DHCP to give us IP addresses. But in this case, we don't have a server. We don't have an appliance like Infoblox, like Windows Server, or even like a router that can give out IP addresses. So for the time being, we're going to have to do static, and that's the only choice we have. Okay, so let's give this a network a Class C IP address. So a Class C private, so 192.168. The next octets, it doesn't matter. And in another video, we can talk more about IP addresses and the different classes and all those things. But for now, let's just focus on the task at hand. And now from here, let's just give it .2, okay? And it's going to have a subnet mask of 255.255.255.0. So what does that mean here? That's basically just saying that this octet right here, this octet right here, and this octet right here, this belongs to the network. And then this one right here belongs to the host, which is the computer itself. To identify the computer, at the end it's .2. But it belongs to the 192.168.2.0 network. Alright, just to keep in mind. Now, let's check after that. Based on this, we set it up here, but let's make sure that we can find out that it was set up properly. And we're going to go on the command prompt. And this is a way that we can find out regarding IP address information and configuration and everything like that. So the command that we can use, does it give us a question mark? Well, it does. So let's see. In this case, we want to learn and know about the IP configuration, right? So we see many different options here, but the one we're looking for here is IP config, displaying the network configuration for each network adapter, and that's what we need. So let's do that right now. IP config, enter. Okay, so we did set it up as 192.168.2.2, which is great for the IP address, and the subnet mask is 255.255.255.0. Well, default gateway, we cannot do anything about that because we cannot communicate outside the network. This is just within the building, right? So for now, there's no default gateway. Okay, so everything's looking fine now. Alright. And now, the thing is that in order for these two computers to communicate, I mean, they need something to connect them with, right? So what type of cable will we have to find out about? Let's see what cables we have in the company here. So there's a console cable, but I don't think that's going to be useful in this case. In the future, if we need other devices, we might need that, but for now, no. Well, we're going to need a twisted copper pair cable here. So which one though? There's a straight through and there's a crossover. And what does that mean? Straight through is basically saying that both ends are the same for the wiring, right? And that means that there's two types of ends. So T568, A or B. So both ends are A or both ends are B. That's a straight through. Crossover means that one end is B, the other end could be A. And the other way around, right? So in this case, how do you know which one to use? Well, for straight through cables, we use them if we want to connect different devices together. But if we want to connect the same type of device together, we'd use a crossover cable. So in this case, are these two devices the same? Of course, because they're both computers, right? So let's bring over a crossover cable. Let's connect that to fast Ethernet on this end, and let's also connect it here to fast Ethernet on the other end. Alright, and we can see that everything is working, everything's up, they're both on, right? And let's say the other engineer here, he tried to set up the IP for this computer, right? And he was thinking, okay, probably he was going to give it as 192.168.1.3 with 255.255.255.0, meaning that 192.168.1 belongs to the network, .3 is the host itself here. And he's going to check whether the command prompt is going to be okay using ipconfig. Alright, and it came up fine. And now let's see if this computer can communicate with another computer. So we had a conversation, we wanted to make sure. He said he set up his computer as 192.168.1.3. I mentioned that I did it as 192.168.2.2. So he was like, okay, we were not on the same page. And yeah, we were not. There's conflict here, right? And why do I say that? Let's find out. We're going to use a command called ping, alright? And we're going to ping this computer, meaning that we're going to try to see if we can reach this computer to see if it works, right? And let's bring that up. The IP address is 2.2, right? So let's try to ping that. 192.168.2.2. And let's see what happens. I mean, we're not seeing anything happening so far. This is not looking good. Request timed out. Yep, something's definitely wrong. We're not on the same page here. Okay, request timed out. And why is that? Well, if these computers are going to be within a building, that means that they have to be in the same network. And according to the IP address and the way the network's set up for both ends, and now that you understand an IPv4 address and a subnet mask and what belongs to a network and what's a host, are these two computers really in the same network? Of course they're not, right? Because the request is timed out. So now let's go over here and let's try to even ping that one. We're going to have the same issue. I can definitely guarantee it. Let's see. And look, request timed out. So the only way that we can solve it is that we can change it to either belonging to 192.168.1.0 or .2.0. So let's change the other computer for now. The manager just said as long as it's a Class C address, that's all he cared about since we're starting small, and just the default subnet mask, which was given by default right here. So let's make that change, IP configuration, and let's change this third octet to a .2. And let's make sure that it came up right and everything is fine, right? Cool. Let's double check that. So let's do that right now by typing ipconfig. Oh, didn't come. Oh, did it come up? There we go. So 192.168.2.3. Perfect. And the other one was 2.2, right? So now let's ping it and let's see if we can reach it. See that they could both speak with one another. Oh, look, there's a big difference. We're getting a reply even back from the computer, and the message is successful. And we can see that we sent 4 packets to that computer, and 4 was received instead of 0 lost. Whereas the last time we sent 4 of them were lost. They were all lost because they were not on the same network. There could be a device that can help in this scenario, and that's going to be for another time, of course. But for now, let's just focus here in the fact that if it's within the same building, we have to have the same networks a lot of times. But there are some cases where that could be different. But we have to have specific devices to make those things happen if there's different networks. But now we can see that. And let's check this computer too and ping it on the other end. And we can see here it's successful as well too. So if it could communicate one way, it could definitely communicate the other way as well. And that's how you simply make a network with one computer to communicate to another computer. And I hope you got something out of this and the way of how to go about it, even if it's something very basic regarding as to how you go through labs. But it's about how you put yourself in a scenario to resolve things and to come up with a narrative. And that's the key component of it. And that's all I want to tell you for today. And until the next video, take care.